Hello friends, welcome to Catalyst Chemistry. As we discussed last class, important point about oxidation. The next one is what dehydrogenation. Oxidation means very simple trick in organic chemistry. In product side, increase the oxygen atom is called oxidation. If the hydrogen atom is going to increase in product side, that is called what? Reduction. Okay. Both the oxidation and reductions are very simple in what? Organic chemistry. Means with the help of the equation or with the help of the reaction, you have to decide this reaction is going on oxidation or this reaction is going on what? Reduction. Okay. That is important point, bear in mind. Okay. In that case, important point is what? One is K-4 potassium dichromate and another one is what? K2Cl2O7. Okay, that is also potassium chromate. Okay, potassium dichromate. Okay, we call no because Cl2 is there, no, we call dichromate. These two are strong oxidizing agent. Okay, strong oxidizing agent means what? Itself undergo reduction. That is most important. Itself undergo reduction means what? That is increase in the hydrogen atom. Okay, that is important. That is why K-4, K2Cl2O7, these two are what? Strong oxidizing agent. After that, one point I told most important for JEE and NEET, that is what? PCC. PCC means what? Pyridinium chlorochromate. Okay, that is what most important point. Okay, that is not affect on the what? Carbon carbon double and carbon carbon triple bond. It is directly affect on what? Alcohol. The alcohol is converted into what? Aldehyde. Up to aldehyde, that is PCC act as a controlled oxidation. What is the meaning of controlled oxidation? If alcohol is converted into aldehyde, means that is controlled oxidation. Again aldehyde is converted into what? Carboxylic acid, that is called extend reaction. But if you are going to use a PCC, up to aldehyde the reaction is going to stop. That is most important role of what? PCC. That point important, bear in mind. The next, after that, dehydrogenation. Dehydrogenation means what? D means remove, hydrogenation means what? H2. The removal of H2, that is indicate what? Hydrogenation. But in tertiary there is no hydrogenation, there is no dehydration, means there must be a water hydration takes place, means what? The removal of dehydration takes place, that is what? Removal of water molecule in water tertiary. Okay, all these things covered in water last class only. Today we are going to discuss the continue some of the reaction on what? Phenols. These reactions also most important for a few exam as well as what? Entrance exam also. Okay, that is why the reaction of phenols, in this case the first point is what? Electrophilic substitution reaction. The electrophilic aromatic substitution reaction, because the reaction of phenol, the phenol is act as a phenol. Okay, the phenol is act as a what? Aromatic. Okay, that is important. That is why electrophilic aromatic substitution. Electrophile means what? The electron deficient, the represented by what? E plus. If the nucleophile is represented by what? Nu minus, general representation shortcut. Okay, the electrophile. In this case, electrophilic aromatic substitution, the most important, if the OH group is attached to benzene ring, okay, that is indicate what? Phenol. The phenol is what? Ortho and para directing group. What is the meaning of ortho and para directing group? The incoming electrophile is going to attack only on ortho and para position, not on the meta position, because the incoming group electrophile is a positive charge. Means in this case the phenol, ortho and para having a what? Electron density is more, negative charge, where there is a one is electron rich, another one is electron poor, then only reaction takes place in organic chemistry. Both the reactions are electron rich, both the reactions means both the reactant are electron poor, means there is no reaction possible. There must be a one is electron deficient, another one is what? Electron rich. Electrophile is electron deficient, but phenol is electron rich, then only reaction takes place. Okay, this is important point. In this case, reaction of phenol, there is a sub headings are there. The first heading is what? Halogenation is there. The next one is what? Nitration. Okay, that is important. These two are reactions are most important. They are going to ask you what? Directly in PU board exam. Okay. After that, what? Raymond-Hyman reactions is there, Cole's reactions is there, that point we will study later. Okay. Just here in this case, the first one is what? Halogenation heading. Halogenation, you know about that, the halogen, fluorine, chlorine, bromine, iodine, astatine is a radioactive element, don't worry about that. But iodine, up to iodine, all are indicate what? Halogens. These halogens will come under what? P block elements. Okay. This point you have studied in PVC first year also. Second year is also there, we will study later. Okay. The starting material is a phenol. After that, this Br2, 3Br2 is there. In this case, they are using excess They are using what? Excess, otherwise, or Br2, you have to write Br2 in bracket excess, otherwise you have to write 3 Br2. 3 to the 6 means totally how many Brs are there? 6 Brs are there. Okay. In this case what happened? This sentence only, if OH is there, in this case what happened? This is ortho, this one is a meta, next this is a para. In this case what happened? Ortho and para directing group, this phenol. In this case what happened? This Br2 is there. No, in this case is Br2, I am going to write like this. Okay. Here one electron is there, here one electron is there. In this point, important is what? These two electrons are completely shifted towards any one of the bromine. Obviously, in this case, one bromine is going to get a positive charge, another bromine is going to get a negative charge. If positive charge is there, no, this is act as a electrophile. This is act as a electrophile. This positive charge is going to attack on what? Ortho and para position. Okay, that is why in this case here is ortho, para, ortho. Okay, what is the name of this one? 2,4,6 trinitrophenol, tribromo. Okay, make it correction, in this case what? Tribromo. Okay, not nitro, in this case tribromophenol, BRO, bromo. Okay, tribromophenol. 2,4,6 tribromophenol plus release of 3 HBr you have to write. If you want you can write, because in this case 3 to the 6 Br are there, no, 1, 2, 3 Br here, after that 3 Br here, totally what? 6 Br. Okay, that is completely satisfy the reaction. Okay, that is why this is most important. In this case, if you are going to use a excess, what is the meaning of excess? Means in this case, how many times you need Br, you have to use that much times, no problem. That is what is indicate what? Excess. Okay. Particularly they are going to give only 1 mole, means what? In that case Br is only 1 mole, but in this case excess means how many times you need, you can use, no problem. That is why in this case what? In this reaction there is a 3 times Br is necessary, that is why the 3 Br is going to attack. But meta, this phenol is not a meta directing group, because meta position is going to get a positive charge. In last video, I wrote all the resonance structure of what? Phenol. In this case, we are going to get a positive charge. The incoming electrophile is also what? Positive. Positive what happen? Automatically repulsion takes place. That is why reaction is not possible. That is why I told initially, one is electron rich, another one is electron deficient. These 2 points are most important. Then only reaction possible. Okay. Next, after that, our plan means we are going to block the position. Just I need only 1 Br on phenol. Okay, that is most important point. That is why in this case we calculated amount of Br2 in CS2. CS2 is a non-polar, okay, non-polar solvent. We can say another name is inert. Okay, that is means what? Less reactive. You have to take Br, that mix with what? CS2 or CHCl3. What is the name of CHCl3? Chloroform. Next, it can gives what? Ortho para product. In this case, what happen? Ortho para products are different products are possible. Means if you are going to use such kind of reagents, means what? These reagents is going to block the position, block the ortho and para position. Just here phenol you are going to take a starting material, Br2 in CS2, again they are going to maintain 273 Kelvin temperature. Okay, there is a formation of first product is orthobromophenol, the next one is what? Parabromophenol. In this case just here only 1 Br is there. In this case para, next one is ortho, these two are what? Block the position with the help of what? Br2 in CS2. This is a what? Minor product. Next this is a what? Major product. Again question, why this is a parabromophenol is a major product? Due to what? Steric hindrance. Br is away from what? This OH group. That is why in this case there is no steric hindrance. In this case what? More steric hindrance is possible, because this Br is very close to what? OH, means what? That is a phenol. That's why this is a minor, this is a what? Major. That's why this is a parabromophenol, this is a orthobromophenol, this is the name. Okay, all these points are most important, bear in mind. Okay, make it perfect. Up to this one is indicate what? Halogenation. Okay, they are going to ask you in examination. Direct halogenation means what? They will mention you have to prepare 2,4,6 tribromophenol. Okay, that is important. The next one is what? Nitration. In exam, competitive exams also most important. Okay, bear in mind. Next one is what? Nitration means what? In this case important point, bear in mind, there is a what? Generation of Br2 plus is act as a what? Electrophile, E plus. Okay, in this case what? There is a generation of electrophile. In this case also there is a generation of electrophile, that is NO2 plus. NO2 plus, okay, this one is important. NO2 plus, NO2 plus is act as a electrophile. NO2 plus act as a what? Electrophile. This is a phenol. They are going to use a constant HNO3, after that concentrate H2SO4. First they are going to use a concentrate H2SO4, after that they are going to use a concentrate HNO3. But in NCERT they are given only concentrate HNO3 in reaction, but after that they are given in what sentence? Okay, nowadays means first they are going to use concentrate H2SO4, there is a formation of what? Sulfonic acid, okay, 2,4,6 trinitro sulfonic acid, after that they are going to add a concentrate HNO3, finally there is a formation of 2,4,6 trinitrophenol. Okay, in this case what, when these two mixtures are mixed with a very low temperature, you have to maintain compulsory 0 to 5 degrees Celsius, then only there is a generation of NO2 plus electrophile. Okay, that is important. After that there is a formation of product is 2,4,6 trinitrophenol. This is a product. Another name for this one is picric acid. This word is important, bear in mind. 2,4,6 trinitrophenol is indicate what? Picric acid. I think you have saw that structure in what? Acidity of phenol. Okay, 2,4,6 trinitrophenol. NO2 is electron withdrawing group. NO2 is electron withdrawing group, automatically what happens? The acidity of this 2,4,6 trinitrophenol is more compared to orthonitrophenol, paranitrophenol. Means obviously very simple trick is if you are going to increase the electron withdrawing group, automatically what happens? The acidity of phenol is going to increase. So this is a fact. Okay. Next one is what? In this case all the ortho and para positions completely attacked what? With the help of NO2, but again in this case my aim is going to block the some position, means just here in this case phenol is a starting material, they are going to use dilute HNO3, after that 298 Kelvin temperature they are going to supply. Okay, in examination you have to write both constant HNO3 and H2SO4, otherwise just you have to write constant HNO3, that is also right, no problem. Okay, that is a dilute HNO3 298 Kelvin. There is a formation of orthonitrophenol, paranitrophenol. This is a minor product, this is a major product. Reason, tell me? Very simple reason. Now only I told, no, due to what? Steric hindrance. In this case less steric hindrance, in this case more steric hindrance. Okay, just here in this case orthonitrophenol is there. Okay, in this case what happened? The para, this ortho going position going to block. In this case also what happened? Ortho, this ortho is going to block. That's why para nitrophenol. Next after that what? In this case orthonitrophenol product possible. Okay, these two products are important. Okay, bear in mind. If you are going to use dilute HNO3, then only you are going to get ortho and para separately. But if you are going to use constant HNO3, 100% you are going to get a what? 2,4,6 trinitrophenol. Okay. Next after that these 2 points are what? Most important point. Okay, this is one is what? Orthonitrophenol, another one is what? Paranitrophenol. Just here in this case orthonitrophenol is a intramolecular hydrogen bonding. This word is the most important. Intra. What is the meaning of intramolecular hydrogen bonding? The hydrogen bonding takes place within the atom. Within the atom, that is indicate what? Intra. Intra means what? Within. What is the meaning of intra? Just see here, here is there, no. Intra means what? Within. Okay, is just here. This is what? Phenol is there. Next this is what? NO2. This NO2 is there. No, that NO2 I wrote in the form of what? Double bond O. Next one is what? Arrow mark. Okay, this is orthonitrophenol only. These two structures are same. But what happened in this case? Here oxygen is there, here hydrogen is there. In this case what happened? There is a formation of what? Hydrogen bonding. What kind of hydrogen bonding? That is intramolecular hydrogen bonding. Okay, the hydrogen bonding takes place within the atom, that is indicate what? Intramolecular hydrogen bonding. Okay, that's why just here in this case this arrow mark is there. Now, this arrow mark indicate what? Covalent coordinate bond. Covalent coordinate bond. This oxygen, automatically what happen in this case? Hydrogen is there. One is a more electronegativity, one is a less electronegativity. Automatically there is a hydrogen bonding takes place. The next one is what? Here is different. The example is what? Paranitrophenol. This paranitrophenol only I wrote, just I tilt like this. Okay, here is there, no, I tilt like this. One more is there. Paranitrophenol means in this case what? Inter. Here is there, no. What is the meaning of inter? Between. Inter means what? Between. Between two molecules. Between two molecules. Here one molecule is there. Here one molecule is there. Otherwise you can say here one compound, here one compound. No problems. In this case what happened? Here NO2 is there. One is the covalent coordinate bond. That is going to what? Combined with what? Means what? Link up with what? Another paranitrophenol hydrogen. This is indicate what? Intermolecular hydrogen bonding. Inter means between two groups, that is indicate what? Intermolecular hydrogen bonding. Okay, that is why most important, bear in mind. Okay, up to this what? Halogenation and nitration completed. Okay, you have to take a screenshot. I will start the next point.